Hi guys, so in this video we will discuss about configuration. So what is configuration? A set of m points where m is our vertex and n lines where n is our side in a plane is called the configuration in the set containing m sub c, n sub d. If each of the m points is incident to the same number of c out of n lines, while each of the n lines pass through the same number d out of m points. Remember that C is the number of lines that pass through the vertex M, and D is the number of vertices or points that lie on line N. Note, C times N is equals to D times N. So now we will proceed to our first configuration, which is the Fano plane. In finite geometry, the Fano plane, named after Gino Fano, is the finite projective plane of order 2. It is the finite projective plane with the smallest possible number of points and lines, 7 points and 7 lines, with 3 points on every line and 3 lines through every point. Next, we have here the figure of Fano plane with a configuration of 7 sub 3. And note that Fano plane is a self-dual configuration, as you can see here. It has 7 vertices and 3 sides that pass through it. And it also have 7 sides that have 3 vertices that lies on it. I will show 7 vertices that have 3 sides passing through it. The first vertex is here. We have this side, and this side. And second vertex, we have this side. And if you're finding the third side, it is the circle. Because in geometry, circle is considered a line. Now we have the third line. We have this side, and this side. The fourth vertex, we have this side, and the circle. Now for the fifth vertex, we have this side, and this side. For the sixth vertex, we have this side, and also the circle. For the last, the seventh vertex, we have this side, last, and this side. Now for the side that have 3 vertices lying on it, we have the first side, which is here, the first side with 3 vertices, the second side with 3 vertices, the third side with 3 vertices, the fourth side with 3 vertices, the fifth side with 3 vertices, the sixth side with 3 vertices, and last the circle, the seventh side with 3 vertices. Now, we will proceed to our second configuration, which is the Mobius-Cantor configuration. In geometry, the Mobius-Cantor configuration is a configuration consisting of 8 points and 8 lines, with 3 points on each line and 3 lines through each point. It is not possible to draw points and lines having this pattern of incidences in the Euclidean plane, but it is possible in the complex projective plane. Now, we have here the figure of Mobius-Cantor configuration with the configuration of 8 sub 3. And note that Mobius-Cantor is also a self-dual configuration because it have 8 vertices and 3 sides that pass through it, and it also have 8 sides that have 3 vertices that lies on it. I will show all the 8 vertices that have 3 lines passing through it. Now for the first vertex, we have here this side, and this side. For the second vertex, we have here this side, and this side. For the third vertex, we have here this side, and this side. For the fourth vertex, we have here this side, and this side. For the fifth vertex, we have here this side, and this curved line, the third side. For the sixth vertex, we have here this side, and this side. For the seventh vertex, we have here this side, and this curved line. For the last eighth vertex, we have here this curved line, this side, and this side. Now, I will show the side with the three vertices that lying on it. Now, for the first side, we have here this side with three vertices. Second side with three vertices lying on it. Third side with three vertices lying on it. The fourth side that have three vertices lying on it. The fifth side with three vertices lying on it. The sixth side with three vertices lying on it. The seventh side that have three vertices. And last, the eighth side with three vertices lying on it. And now, for the last configuration that we have to discuss, we have here the gray configuration. The gray configuration, 27 points and 27 lines meeting 3 lines to a point and 3 points to a line, drawn as a perspective view of a three-dimensional grid. I will now show all the 27 sides that have 3 vertices lying on them. So, we have here from the top, we have here 3 horizontal lines and 3 vertical lines that have 3 vertices lying on them. So from the top we have 6 sides. So from the middle we also have 3 horizontal lines, these lines, and we have vertical lines that have 3 vertices lying on them. So all in all we have 12 sides. From the bottom we have also 3 horizontal lines and 3 vertical lines that have 3 vertices lying on them. So we already have 16 sides. So from the upward position, we have 3 from here, 3 sides that have 3 vertices lying on them. We also have 3 from here, and we have also 3 from here that have 3 vertices lying on them. So the total sides we got have 27 sides. And that's it. That's all for today's video. Thank you for watching.